The problems in section 6.1, they basically all have the same instructions, and those are the instructions I've written here. You're trying to find the area of a region enclosed by curves. Sometimes they'll give you a picture, but if they don't give you a picture, you really need to draw the picture. Even if they don't ask you to draw the picture, you need to draw the picture because otherwise you're not going to be able to figure out what you're supposed to do. So whenever I have a problem like this, I see a problem like this, the very first thing I want to do is draw the picture. So for number 12, they've given us two curves and two straight lines, right? X equals -1, x equals 0. So let's just try to draw those. That's our first step. Yep, yep. So y equals 1 plus x cubed. That's x cubed plus 1. So it's x cubed, and I'm moving it up 1. So here's 1, right? This is also 1, -1 actually. Let me write it down properly, right? This is y equals 1, and that's x equals 1. All right, and then y equals 2 minus x, that's y equals minus x plus 2, 1, 2 here. That's gonna look something like this. Whoop. Okay. And then x equals -1 and x equals 0. Those are gonna be here, right? So what I'm really looking for is this region, this yellow region here. And they gave me all this information. Like this is the information that comes with the problem. They'll tell you what the curves are. And sometimes you'll have to find out, as we saw in class, sometimes you have to find out where things intersect. Other times, like here, they're just going to give you the bounds that they want. So let's label our graph here. This first curve was y equals 1 plus x cubed, and this second curve was y equals 2 minus x. All right, now if I'm going to, and I could have drawn this bigger, now I feel that, but that's life. So if I'm going to do the area of this region, I want a rectangle, and the rectangle between these two curves, I'm going to say it's going to look like this. Now, how do I know I want to do x versus y? Rather, in other words, what I'm saying, this is going to be my dx, right? That's my thin rectangle. And that's the width of the rectangle in this case is dx. The height of this rectangle, we're going to do y1 minus y2, meaning the top curve minus the bottom curve. This is why it's so great to have a picture, because I can immediately see this is the top curve, y1, and this is the bottom curve, y2. So maybe I didn't know that to begin with, but once I have my picture, I can easily see on the region that they're asking me which one is the top and the bottom curve. Okay. If they ask me a different region, I might have a different y1 and y2, obviously. So I'll have to check it out. So the area then is going to be, because I know I'm integrating with respect to x, I'm going to go from no, I'm going to go from -1 to 0 of y1 minus y2. So this is 2 minus x minus 1 plus x cubed. Okay, so that's my integral. Now we all know how to do this integral, and I'm going to go do it in a second, but let me just say, why did we choose x instead of y? Well, in other words, why did we choose to integrate with respect to x instead of y? Well, if I were to integrate with respect to y, let's see what that would look like. It would look like going this way, right? So, but if I look at this couple different possibilities, I could do that. I would have to break this up into three different regions where there was going through all these different curves. That's a lot of work. I can certainly do it, but I don't want to do all that work. That's way too much work for me, right? Because on each of these three different regions, let me kind of draw it a little bit better. Hold on. Let me put a So those are those three different regions where I'm bounded on different sides, right? I've got the square in the middle, I've got a triangle on top, and then some curve in the bottom. So I've got all that. I would have to do it in 3 different regions. Absolutely a huge pain in the ass. I don't want to do that at all. So by choosing correctly, the dx being the width, I'm and my y, I'm just going the bigger curve minus the smaller curve, and it's the same curve the whole time. So easy. And now I have an integral, which is not too bad to do, right? So, let me just 2 minus 1 is 1, right? So 1 minus x cubed. So I can easily integrate x minus x squared over 2 minus x to the 4 over 4, evaluate from -1 to 0, right? So it's going to be, all those are going to be 0 minus 1 minus 1/2 minus 1/4. So the minus and the plus, what is this? 3 plus 4 is 7/4. Oh, I forgot my 7/4, like that, right? So that's my answer. Notice it should be positive. So that's a good check. If I had made a mistake with my curves, if I took the wrong one minus the wrong one, I get a negative answer. I know I did something wrong. So even then, let me reiterate that. I've said it multiple times, so let me reiterate that. Whenever we're doing area between curves, it always has to be positive answer because you're taking a bigger one minus a smaller one, no matter where it is. It's not the same as just area under a curve. Basically, what I'm doing when I do area under the curve, I'm always doing the area of that curve minus the x-axis, right? So that's why it comes negative if it's underneath. But area between two curves always has to be positive. All right, let's do another one. So this one, all right, what's this? Now I have to draw again. So here's my graph, x and y, and I'm going to do x equals y or y equals x. That's easy, right? So we'll do that. We know that. But what's this? This has an x and a y squared rather than a y and an x squared. So we know this is going to be some kind of parabola, but it's going to be on the side somehow, some weirdness. So I'm going to solve, if that helps me a little bit. This one might help me more, but I'm going to solve that curve. Now, how do I draw that curve? Okay, yeah, you could use decimals or whatever, but if you don't, how do I draw that curve? Well, it helps to know it's a parabola. Like you would know it was a parabola if the x and y were switched, so it's just a parabola, but it's horizontally, right? So if I put in, let's do just a little bit of sketching here. If I put in x equals 0, okay, that's everything that's on the y-axis. If I put in x equals 0, I'm going to get y squared equals 12, or y equals square root of 12 plus or minus. So what is that, 2 root 3? So whatever that is, kind of somewhere over here, right? Not whatever. So I have two possibilities there where it's going to cross the y-axis. And then what happens when y equals 0? So y equals 0 is on the x-axis, right? So that would be y equals 0. That's going to give me 4x equals 12 or x equals 3. All right, so we're here, and that plus knowing that it looks like a parabola is enough to sketch my curve. All right, that was horrible. Let me try that again. It's enough to sketch my curve. Good enough for me, right? So now what we're looking for is this section here, right? The section that's enclosed by the curves. Okay, so I'll shade that in. And now what? Well, what's better, X or Y? So if I think about what I had done before, if I do Y, if I do X, all right, let me see let me be clear, which I'm not being clear if I say if I do Y or if I do X. So let me ask, let's write it down. Integrate with respect to X or Y. So if I integrate with respect to X, Then I've got a dx. That gives me um something like this, right? But that means I have to worry about this guy where I've got it between these two, and then I have to worry about this guy when I've got in between these two. So, let me say, with respect to x, I need the curves as y2 minus y1, but they're actually kind of written not that way, right? They're written in terms of x and and two regions, right? Because the region that would be like this, the region to the left is between the line and the curve, and the region to the right is between these two curves. So that's kind of messy. We don't like that. Okay. So if instead we're going to do it with respect to y, all right, let me get rid of all this. Unfortunately, there's not an easy way for me to. Uh, Boy, this is terrible. I'm just trying to get rid of. Oh, it won't do it. I'm just trying to get rid of these guys. I have to figure out a better way here, but I don't know it. So if I get rid of, see, that's what I didn't want to do. I wanted my guy like this. I know there's better ways to do this, but maybe I don't know what they are. All right, so with respect to y, I have something which looks like this. I'll use red. Okay, that looks a lot better for me because this guy is the dy, and then this guy is going to be x2 minus x1. So I have only one region because I'm always taking, so x2 is going to be the one on the right. So this is always right minus left. And how do you know that? Right minus left. Because I want the one that's bigger, meaning is the one that's more positive. So remember, the further we go on the x-axis, the more positive we are. Okay, so it's bigger in the sense of being more positive. Um, so with respect to y, I have that my where was I? That I have x2 minus x1 is height, is the width. One region, not two. Okay. Which is going to tell me, oh, you know what? I should write this curve. I forgot to put it on my, I forgot to label this a little bit better. Okay, so that's going to tell me that what I want for my area is going to be the integral, okay, from what to what, we'll get there, but x2 minus x1, so the one on the right minus the one on the left, which would be, this is going to be my x2, and then the other one's going to be my x1. So we would have 3 minus 1/4 y squared minus xy, right? Because we're doing with respect to y, right? So this would be x1. Oh no, wow. I'm having some real problems here. Sorry, bad tech, bad, probably user error. Okay, so far so good. So that's my area integral, but I need to find my endpoints. So I'm gonna get rid of this and use this area to find my endpoints. So to find my endpoints, now I need to find the y values, the y value of where these two guys intersect. So I'm going to set the two curves equal, right? See where they are. There we go. I'm going to set those two curves equal. Obviously, when they're equal, um, x equals y, so I can just plug in y for x for y here. Or I can set the two equal and then, well, it's the same thing, right? This may be a little bit easier. So this gives me y squared plus 4y minus 12 equals 0. Well, we know how to factor that. So that would be plus 6 and minus 2. So that gives me y equals negative 6 and y equals 2, which, okay, that looks at least somewhat reasonable. So this would be 2, and this would be negative 6. And so maybe my picture isn't as to scale as it should be, but like that's life. Okay. So now the rest of this is easy enough. Integrate this. I'm going to have 3y minus 1/4 times y cubed over 3 minus y squared over 2. And I'm going to evaluate it from 2 to negative 6. So let's see what I have. 6 minus 1/4 times 8/3 minus 4 minus, okay, negative 18 minus 1/4 times, oh, but what the heck? Feel like, yeah, so this is, yeah, okay, that's that, yeah, that works. So, okay, wait, I have to be careful about my negatives. Minus 36 over 2. Okay, that's it. So this is 6 minus 2/3 minus 2 minus negative 18. So what the heck is this? This is 36 times 6 over 12. So this is 36 over, sorry, no, 2. So this is 18. So negative 18 plus 18 minus 18. So those 18s, lose them. I get 18 plus 4, 22 minus 2/3, which is 64 thirds. That's right. Okay.